Good morning, class. We are looking at further applications of trigonometry functions, the law of sines. So we are going to look at the law of sines, the law of cosines, polar equations. The objectives for this section, the law of sines, section 8.1 is that solve SAA, side angle angle, or ASA, angle side angle triangles. Solve SSA, side angle triangles. Solve applied problems. Again, refreshing everyone's memory about the fundamental identities. This is the unit circle x squared plus y squared equals 1. A point x comma y is represented as cosine and sine. All trigonometric functions are odd functions except cosine. Cosine of minus x is cosine x. And therefore secant of minus x is secant x. Those are even functions. All trigonometric functions are periodic with a period of 2 pi, except tangent and cotangent with a period of pi. When we have a right triangle, a squared plus b squared equals c squared, and a plus b adds up to 90 degrees. Pythagorean identities, starting with sine squared plus cosine squared equals 1 and the rest of them. Quotient identities, starting with tan equals sine over cosine. Reciprocal identities, starting with cosecant, is 1 over sine and the rest of it. Sum and difference formulas are discussed here. Sine of alpha plus beta is sine alpha cosine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. There are many formulas. Hopefully everybody remembers them. Double angle formula, such as sine of 2 alpha is 2 sine alpha cosine alpha. Cosine of 2 alpha has three different formats: cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. And sine of alpha over 2, and before that, we should look at sine squared alpha, which is 1 minus cosine of 2 alpha over 2, coming from these formulas. Okay. Cosine squared alpha is 1 plus cosine 2 alpha over 2, and you cut it in half. Tan, of course, is the ratio of sine to cosine, and from here we can get the half angles as well. And over here, product to sum, that we really didn't discuss that, but it is here in case anybody is interested. So going back to the right triangle, what comes with that? Sine theta is the opposite over the hypotenuse, in this case, P over C. And cosine theta is the adjacent over the hypotenuse, in this case, A over C. And as long as we know these two, we can figure out the rest of them. Tan is the ratio of sine to cosine, which means the opposite over the adjacent, opposite over the adjacent. The rest of them are the reciprocals. If you have a line of sight, okay, and you're looking up compared to the horizontal line, then the angle it makes with the horizontal line, the line of sight, it's called the angle of elevation. If you're looking down, the angle it makes with the horizontal line, this is known as the line of sight. This is the angle of depression. There are two ways to look at the bearing. Method one, you just compare it to the north and you go clockwise. Okay. In the case of a second method, direction to or bearing of a point O to point P, you start always with either north or south and the closest angle to it. For example, P1 has a 30-degree angle. So you start with north, then the angle, and it's to the right of it east. If you look at P sub 3, it's north 70 degrees west. P sub 4, you start with south because this is the smallest angle, right? Closest to the south. So south 20 degrees, and this is to the right of it again. It's east, whereas this one, again, you start with south 50 degrees west. So those are the bearings we've seen. Now, solving oblique triangles. What is an oblique triangle? It's a triangle that none of the angles is a right angle. If you look at this one, all angles are acute, meaning it's between 0 and 90 degrees. If we look at this example, these two angles are smaller than 90 degrees, are acute, and one is obtuse. So acute angle A is between 0 and 90 degrees. Obtuse angle B is between 90 and 180 degrees. There is a sign missing here. And when we have a general oblique triangle, such as this one, the way we name the triangle, A, B, C are the vertices. Opposite A is lowercase a is the side, is the length of this side. Opposite the vertex B is lowercase b is the length of this side. And this is vertex C. Opposite that is lowercase c, the length of this side. And here's the sine law, or the law of sine, that says sine A over lowercase a equals sine B over lowercase b, or sine C over lowercase c. And of course, we know that the interior angles are supposed to add up to 180 degrees. Now we are going to look at the proof of that shortly, but that's the general idea, everybody. All right, so I put the sine law here, and we're going to, again, elaborate on that and discuss that and prove that. Cases of solving oblique triangles, none of the angles is a right angle. Here's the cases. One case, or you can call it case one, is ASA. So angle, side, angle. So we have two angles and the side in between the two are known. SAA. So although there are two angles known here, but the side is in between. Although there are two angles, the side is not in between. So the side is not between the two angles. So side, angle, angle. So blue means no. Side, side, angle. So we have two sides and the angle is not in between. That's important. Case number 3, SAS, side, angle, side. That means it's the included angle. It's the angle between the two sides. Case number 4, SSS. All sides are known. So a quick recap. Case 1, there are two angles and the side in between. We call it ASA. It is still case 1. We have two angles, but the side, unlike that, is not in between. Now we have two sides and an angle. Two ways it happens. One is that the angle is not in between. One is that the angle is in between the two sides. Finally, three sides are known. So those are various cases we are going to look at. Case number 1, we have two angles on a side. In this case, the side is in between. In this case, it's not. ASA, angle, side angle, and SAA, side angle. One side and two angles results in one unique solution. So we have a unique solution, and therefore just one unique triangle. Case number 2. SSA. SSA, side angle. Two sides and an angle. Opposite one of them could result in several different situations and solutions to occur. Consequently, SSA is referred to as the ambiguous case. So several cases can happen. If A is acute and lowercase a equals H, one trial exists. So if one side A is equal to the height, if you drop a height, okay, drop a perpendicular, that's what happens. So that's the acute angle. If A is acute and H the height is less than both sides A and B, it's less than B, and B is less than A, one triangle exists. If A is obtuse, A is larger than B, one triangle exists. Again, we will look at all of these cases. If A is acute and A, one side is less than H, then it can't happen. No triangle exists. If A is obtuse and A is less than or equal to B, no triangle can happen because actually the largest side is opposite the largest angle, and if this is the largest angle A must be larger than B for it to exist. So we have acute angle. In this situation, H, the height, is less than A, and A is less than B. Since A is larger than H, a triangle is created, but since A is smaller than B, it can swing to the left and H to the left of H and create a second triangle containing an obtuse angle. What do we mean by all of this? This is the synopsis of the whole thing. We will look at all those cases, class. Okay, so this is the synopsis of dealing with those cases. Case number 3, SAS, side angle side. SAS, side angle side, two sides, and the included angle, the angle in between, results in one unique solution and one unique triangle. It gives us only one, precisely one. Case number 4, when we have all the sides, SSS. Three sides results in one unique solution and one unique triangle, as long as one side is smaller than the sum of the other two sides. And we have to go with the cosine law, the next section, to solve this. So those are various cases, everybody. Let's start with the proof for the law of sines. We have the following triangle ABC. So the sides are lowercase a, lowercase b, lowercase c. Is the altitude, the height. And this is angle B. Sine of a B in this smaller triangle, because it's cut into two, and you drop a perpendicular, it's the opposite, which is H, over the hypotenuse, which is C. So in this triangle, H over C. Therefore, what is the value of H? The product of these two because of the cross product. So H becomes C sine B. Now, in this one, on the right side, everybody, you want sine of a C is the opposite, which is H, over the hypotenuse, this time is B. So in this one, okay, the right side. Remember, it's a 90-degree angle. Sine of C is H over B. Therefore, in this case, H is the product of these two, B sine C. So those are equal because both of them equal to H, right? Okay, so let's hold on to that. If we divide both sides by lowercase c times lowercase b, in other words, divided by bc, in this case, c drops, and in this case, b will drop from the bottom and the top, and we get this one. Sine b over b equals sine c over c. It's a portion of that sine law, right? in essence, if you look at the bottom, they have written 3 of those. And you can prove 3 of those, and then you set all 3 equal. So we proved, in essence, this part, right? Let's repeat the same process with the altitude drawn from point B. So if this was the altitude drawn from point A, from point B, you draw a perpendicular with a 90-degree angle. It looks like this, right? Now for this little triangle, the one on the left, this one, okay, we are looking at this angle, okay? In fact, so we are looking at this one, okay? Now, sine of A is the opposite H over the hypotenuse C. Now for this one, let me shade it in green. For this one, if you want sine of C is the opposite H over the hypotenuse A, okay? We do the cross product just like this one, just like this one. So H is the product of these two, C sine A. H is the product of these two, A sine C. Because both of them are equal to H, we can say these two are equal. C sine A and A sine C are equal. We're going to divide both sides by A times C. And it results in sine A over A sine C over C. And if you look at this one, let's say number 1, and look at this one, let's say number 2, sine A over A is equal to sine C over C, therefore equals to sine B over B, and that's a proof of the sine law. So we proved sine A over A equals sine B over B equals sine C over C. Let's look at an example. Using sine law to solve side angle, this was case number 1. So solve the triangle when A is 40 degrees, B is 60 degrees, lowercase a is 4. In other words, 2 angles are given with one side. Now they may give you a triangle, they may not. You can make up a triangle of your own and give them the names that you want, and they don't have to be to scale, just to get you started. In this case, they have given us 2 angles, 40 degrees and 60 degrees. So when they say A is 4, that means this is capital A. Since the opposite is lowercase b, This is capital B, and C is given. So this is C, this is C. This is capital C, this is lowercase c, okay? But just in case, because A equals 4, and this is capital A, and because they call this lowercase b, this must be capital B, as far as the information. Now, the easiest one would be to find this angle, because 40 plus 60 plus C must add up to 180 degrees. So the first thing we do, we find C, which is 180 minus the sum of those two. Again, the sum of all interior angles is 180 degrees. So this one plus this one plus this one is 180. So that becomes the angle C. Now let's use this and whatever we have here. Because we have this side, this must be used. So according to this formula, I can say sine of A, or just 40 degrees over A, or 4, is now any of them. For example, this side, sine of 60 degrees over the lowercase b, and find the missing b. We do the cross product. So 4 times sine 60 is b times sine 40. Or you may recognize b is the product of these two divided by sine 40. Okay, so sine 40 divided by 4 equals sine 80 over c. For the other one, by the way, because we want to find lowercase c, we write it in this fashion. So there are two of them. In order to find the missing sides, b and c. So again, the cross product. And I hope you see that this one gives you b equals 4 sine 60 over sine 40. Just in case, if you need to see that, I'm going to write b sine of 40 degrees is 4 sine of 60 degrees. And if you divide by sine of 40 degrees, you get that. Now, needless to say, you have to use a calculator here. So you put it into a calculator, 4 sine 60 over sine 40. By the way, sine 60, we know it to be square root of 3 over 2. But we don't know what sine 40, we want an approximation. And as far as the approximation is concerned, normally we go with 1 or 2 decimals unless they mention. So in this case, if we go with the second one, because next to it is 9, we take it up, so it becomes 5.39, okay? Because of this number 9, it goes up. For the next one, C is 4 sine 80, okay? C, you want C, so the product of these two divided by sine 40. So we write this as 539. And what I want to do, okay, I want to first of all, I want to write this is B. Secondly, from here, I can write C sine 40 is 4 sine 80. When we divide by sine 40, we get that. Again, we're going to use a calculator class. Okay. Same way I showed you here. And then we go with the approximation. We get 6.13. And so now we have this one as 6.13. And we have solved the first case, side angle. So two angles, okay, are given. Here's ASA angle, side angle. Solve the triangle. A is 35 degrees, B is 15 degrees, C is 5. So let's just if A is 35 degrees, B is 15 degrees, so AB and this is C. So opposite capital A is lowercase a this side. Opposite capital B is lowercase b. Opposite capital C is lowercase c, which is 5. First and foremost, two angles are given. Immediately we find the third one. So we add them up, subtract from 180. 15 and 35, 50, subtracted from 180, you get 130. So we have this angle. It's 130 degrees. We're going to use the sine law. Sine A over A is sine C over C. Why sine C? Because this is given, we have to go with sine C. There is only one side is given. So sine A, all angles are given now. When two angles are given, the third one in essence can be easily found. So you can think of three angles are already given. It's very straightforward. And so then whether you left with whatever side that they have given us. So the angles, again, two angles are given, immediately you get to the third one. So all three angles are known. One side is given. So in the sine law, you have to use the side that is given. So this must be used. Okay. Now it doesn't matter you put sine B over B or sine A over A. You have to do both of them anyway. So let's start with sine A over A. So sine A, sine of 35 degrees over lowercase a, which we don't have. Sine C, sine of 130 degrees. Over lowercase c, we know it to be 5. And now again, by now, again, everybody is comfortable with the cross product. I don't want to, waste too much time. But I'll show you one more time here that A sine of 130 degrees is 5 sine of 35 degrees. And all you have to do, divide by, remember, sine of 130 is not missing. You can use a calculator. So divide by sine of 130 and use a calculator. So 5 sine 35 divided by sine 130 is the answer. And roughly 3.74. We went with 2 decimals. I highly recommend you use a calculator, know what you're doing, and take it from there. And so we're going to use the same thing, but this time instead of sine A, we're going to go with sine B over lowercase b. So this is 3.74. Sine B over B is sine C over C. So the right side is identical to this. What about the left side? Sine of a B, sine of 15 degrees, and lowercase b is missing. Again, the cross product class. Let's write that one also. B sine of 130 degrees equals 5 times sine of 15 degrees. Divide by sine of 130 again. Use a calculator. Come up with 1.69. And that's the value of P. So we looked at case of two angles and one side. One was SAA, side angle. One is ASA. In this case, the side is in between. So the side 5 was between the angles A and B, everybody. It's called the included angle. Side angle, it is also known as the ambiguous case. We have two sides and an angle that is opposite one of them. So A and B is given, and angle A, which is opposite one of them. H in this triangle is B times sine A, because sine of A is H over B. Sine of A is the opposite H over B. Therefore, H is the product of these two pieces, B times sine A. If this side A is less than H, which has the value of B sine A, there is no triangle because it never reaches the other side if A is smaller than H. Why is that? Remember, the shortest distance would be a straight line. So the shortest distance is this one, right? Now, if this is shorter than the shortest distance, it can never reach from this point, from this vertex, it can never reach this side. In order for it to reach this side, must be at least equal to H. If H, which is B sine A, is less than A, and A is less than B, there are two possibilities. There are two triangles. We will see that when we look at examples for ourselves. The triangles could be the larger one or just this one. Would be this one, okay? So either the large one, or this one. This is the second one. The complete one is the larger one. There are two possibilities. So we said, and we shown that H is B sine A. If A is larger than or equal to B, we have a one triangle. And if A is equal to H equal to B sine A, we have only one, and that's a right triangle. So if A is precisely equal to H, we have one triangle. So let's look at one example of that. All right, we're going to look at SSA, and I put one here that ends up having one solution. We want to solve this triangle where A is equal to 3, B is equal to 2, and A is 40 degrees. So again, when that happens, you can draw some sort of a triangle and try your best. It doesn't have to be to scale. And let me call this A. This side is given as B, but let me just write it underneath P. And this side is written as C, as you can see, but let's write next to it. So A, B, C, where A is 40 degrees. Now let's also write A here, B here. This is lowercase c. All right, so we are going to write the sine law, everybody, and we are going to use whatever we have. Obviously, because there's only one angle A known, we must write sine A. You see that we have no choice. Sine A, so sine of 40 over lowercase a, so we are going to write this. Sine A over 3, sine of 40 over 3. And then because B is known, sine of B over 2. So I hope you see why. According to what's known, we write this part. We use this part, everybody. Cross product. Again, let's just quickly do this. There's 2 sine of 40 degrees and division by 3. Using a calculator at this point, 2 sine of 40 degrees divided by 3. Using a calculator, I highly recommend you go with a lot of decimals in the first place, and because you want to have a precise answer, and then you can do the rounding. So it's about 0.43. So we have sine of B. So what is B? Sine inverse of 0.43. Sine inverse of 0.43 using a calculator will give you 25.4 degrees. Now here's what makes this ambiguous, because there's more to that when you find the sine. Remember, sine is positive in the first and second quadrant. So I call this B sub 1 instead of just B. Because if sine of B is 0.43, and the angle is 25.4 degrees in the first quadrant, if we subtract this from 180 degrees, in the second quadrant, it becomes 154.6 degrees. Again, this one in the first quadrant, this one subtracted from 180 in the second quadrant. Now, whether it's going to work or not, this is what happens when you go through the process. Three things happen. Number one, a case like this. When that happens, you are going to say, I need three angles, the sum must be 180. If the sum of this one and this one is more than 180, this is out. So I want to make sure we understand why this is out. If this angle plus this angle is less than 180, then you have one case and case number two. Let's make it up. Let's say this was 120. 120 and 40 is 160. Then we have a third angle 20 degrees, so it can work. So if this angle plus this angle is less than 180, it works. You have two cases. If this angle plus this angle is more than 180, or the plus 154.6 larger than 180 degrees, then it does not work, meaning forget it, just you have one triangle. Okay. The third case is when this number is larger than 1. If sine is larger than 1, it can't be. Remember, sine is between -1 and 1. Then there is no case. So you could have one solution, as it is the case here. You could have two solutions if this was such that the sum of these two would be less than 180. And the third case happens when this number is larger than 1, it doesn't work. So in this case, we prove this one doesn't work. We just continue with B1 and we just call it B. So we have 25.4 degrees here. We have 40 degrees here. We can add them up. 65.4 subtracted from 180. So C is 180 minus the sum of these two. We are using B1 only. And (180 minus) (65.4 degrees). Degrees a little bit too large. Is 114.6 degrees. So we have all the angles. We have A, we have a B or B1, and we have C. The sides, we have two of them. So we have to use this one because we are looking for the last one. And we can use that one, but we better stick with what we know, okay, already. So this is 114.6 degrees. So we are going to go with sine A over A because both of them are known, okay? You always use the known values because you don't want to take a chance. Cross product. So C times sine 40 is the product of these two pieces. C is the product of these two pieces divided by sine 40. I've shown you that a number of times. And you work it out. So you use a calculator, and with a bunch of decimals, you end up with 4.24. And now you can write all of them. So we have all the sides, all the angles, and we're done. So this ended up with one unique answer, side angle. Let's look at another example. Again, we have a side angle, case number 2 of that. A is 35 degrees, lowercase a 6, b is 8. And we want to solve it, meaning we want all sides. So one more side, we want all angles, 2 more angles. So we are going to use 2 of this. This is 1, 2, 3. Okay. So because a is known and lowercase a, obviously sine a over a, sine a over a, sine of 35 degrees over 6. And then since b is known, sine of b over 8. Cross product, 6 sine b is 8 times sine of 35. So 8 times sine 35 divided by 6 is sine b. So just multiply this by 8. Do you see that? Multiply this one by 8. This goes away, you have sine b. That's another way of looking at it. Multiply. So just both sides by 8 becomes sine b. Using a calculator, putting it into a calculator, we end up with 0.7648. And again, you really want to use a lot of decimals. You do the rounding at the end class. So over here, if I'm calculating this, I'm going to use as many decimals as possible because I want my angle to be precise. Therefore, what is B, the sine inverse of this number? Sine inverse of that requires a calculator, and we go with 49.9 degrees. I'm going to call it B sub 1 because sine inverse gives me a unique answer in the first quadrant. But as you know, sine is positive in the first as well as the second quadrant. So if I subtract this from 180, the angle also has a sine equal to this number. So 180 minus 49.9 is almost 130, so 130.1 degrees. Now, does this work or not? In other words, we work on, definitely we can work on this and finish it. What about this one? Does this work or not? Can we work on this? Anybody? Do you think it works? Yes or no?
Yes.
Yes, it does, because take a look. If we add these two numbers, everybody, I'm talking about the angles. 35 and 130.1 is 165.1. The sum of these two angles is less than 180. That means we can make up the third angle. That means we can continue in this column, and that would be the first triangle. We continue in this column, and that would be the second one. And therefore, we have two possibilities. That's why SSA, side angle, is known as an ambiguous case. So starting with this, because this is 49.9, we're going to add it to 35 and subtract it from 180, or 180 minus 35 minus 49.9. So this is the way it's going to look like ultimately. So this would be one possible triangle, and the larger one, the entire one, would be the second one, okay? All right, so 35 and 49.9 will be subtracted from 180. By the way, we can call this A, B1, B2, C. And by the way, notice B1 is 49.9, whereas B2 is obtuse, is larger than 190. My apologies, larger than 90, less than 180. So, B2 is this one. Okay. All right. 180 minus A minus B1. That means 180 minus 35 minus 49.9, and it becomes 95.1. So we have all angles. We have A to be 35 degrees, B1 to be 49.9 degrees, and C to be 95.1 degrees. Sine A over A, that means sine of 35 over 6 equals sine B over B, or sine C over C. In this case, sine C over C, because we already have the lower case b as well as uppercase b. So sine of C1, or 95.1 degrees over C, and again, we're going to call it C sub 1 because there are two possibilities for C, everybody. C for the big one is AB1, this side. For the small one, be AB2. Okay, so from A to B1 is what we are getting at. And so cross product, again, you want C1, so cross product of these two divided by sine of 35. Again, by now we've done many of them. We should be comfortable with that. Plug it into a calculator. Bunch of decimals. 10.42. This is the distance from A to B1. This is the C sub 1, we call it, this distance. Okay. B is 8, A is 6. And we have all the angles. Now going here, we're going to add these two and subtract it from 180, or 180 minus A minus B2 gives us 14.9. So there are two angles. We subtract them from 180, their sum. 14.9. So we have all the angles. One of them is 35 degrees, one is 130.1, one is 14.9. If you go in this case, this little angle, this one, is 14.9 degrees, and this one is 130.1 degrees. So we use exactly the same thing here, but this time C sub 2. So sine of 35 over 6 is sine C, in this case, sine of 14.9 over C, and we're going to call this C sub 2. Cross product will do the job. C2 times sine 35 is 6 times sine 14.9. So the product of these two divided by sine 35 gives you c sub 2. Use a calculator. 6 times sine of 14.9 degrees divided by sine of 35 degrees. And with a bunch of decimals, gives us this value 2.69, which means this distance, everybody. AB2, this distance is 2.69. So we have two triangles. So take a look. The big one, this 10.42 is the side C. The 2.69 is the side C for this one. Okay, the smaller one, the smaller triangle. Let me again do this. This is one of them. And the big one. This is C sub 2. This is B sub 2. This is B sub 1. So everything is given here if you look at this triangle. I'm going to look at the last case and then we revisit that next time just to be on the safe side. So A is 2, C is 1, capital C is 50 degrees. And with that, we're going to use this last part, sine C over C. So sine of 50 over 1, if you will. And we have A sine A over A. So we're going to use that part because those are the given. So all you have to look at what's given and pick the two that work. So sine A is missing. Lowercase a is true. Sine of capital C, sine of 50 degrees, and lowercase c is known as 1. And again, the product of these two is the product of these two. So 2 times sine 50 divided by 1. Simply 2 times sine 50. Use a calculator. It gives you 1.53. There is no triangle. Why not? Because sine can't be larger than 1, and it ends up with a case like this. Right? Sine is between -1 and there is no solutions. There is no triangle. So we looked at all cases. One solution, two solutions, and none.